Watching and listening to the wildlife in the forest is always a lot of fun, but it can be difficult to get good photos because they often don't sit still for very long. You should be able to identify the two on the left, but the one on the right might be a bit more challenging. If you're a bit of a bird watcher, you might recognize it as a red-breasted nuthatch. It's a very pretty little bird that feeds on insects as well as seeds and fruit. We are now a couple of 100 meters further along the trail, and clearly from the earlier pictures we can see that the structure of the forest has changed quite a bit. There's still we can see a ground layer quite clearly, ground layer of plants in the forest here, and quite a thick shrub layer with these overarching branches. Can you identify that species making up this most of the shrub layer here? But where's the canopy layer? It seems to have vanished or disappeared. We don't see any large conifer trees here. Can you think of any reasons why the forest has changed in its structure like this? Just a little further along the trail and we come to this large open clearing. Wow, this is very different from the starting point of the trail. Changes in vegetation can sometimes be caused by natural variations in the type of minerals that we find in the soil. In other words, the changes in geology or the underlying rocks and minerals, the thickness of the soil or depth, variations in the amount of water moisture in the soil, or even the organic content. And even the slope of the soil or the landscape can affect vegetation changes. But other times they can be caused as a result of human influence. Given the history of this area and its earlier use by people as a farming area, the changes that we've seen here, this open area, is probably most likely a result of this area being cleared in the past for human farming, growing crops or perhaps grazing some animals. When the natural forest has been cleared or disturbed by humans, it often provides an opportunity for exotic plants and often animals as well to gain a foothold, and this is the case here. We're going to take a look at a couple of these species now, and you can already see some of them in the photo here. The daisies in the foreground, for instance, may be very attractive, but they're actually an invasive species. The daisy growing in the open meadow here is the ox-eye daisy. It's a very pretty flower, but it's also an exotic invasive plant. It was introduced from Europe and grows quite prolifically wherever it has an opportunity to germinate its seeds. The problem with invasive species, even if they're pretty ones, is that they often, by their aggressive growth, they take over an area and reduce native plant diversity. And it makes it very difficult for the native species to become re-established. In some cases, however, invasive species can also provide some kind of benefit, such as providing a food source for flies, such as this one. There are quite a few other exotic plant species growing in this same open meadow area, including the rosebush shown above and the hawthorn tree on the left. You don't have to remember or identify any of these exotic species, but it's important that you realise that in many of our local parks and gardens and natural areas, there are a surprisingly large number of exotic and sometimes invasive species. And we shouldn't just assume when we go to these areas that they're all native. This plant is also quite abundant in the open cleared area. but this is the native bracken fern. It's a bit unusual for a fern because not many ferns can tolerate full sunlight like this one can. Once again, this is not one of the plants that you are required to know, but I wanted to include it here so that you get a sense of the diversity of ferns that we have in our local area. Most people recognize a crow when they see one, and these are a common native bird species in the area. They're very intelligent and very social birds, but they can also be very much a pest. Unfortunately, we also have some invasive animals in our parks, and this is one of them, the invasive black slug, introduced from Europe, I believe. But one interesting thing about mollusks here is on the front end of, or towards the front of the animal, on the side, you can see a kind of opening in the body. This is a cavity, and it's the lung cavity. This is where and how the animal breathes. And this is, you find the same structure on other slugs and snails. The trail now passes through another section of shady forest, and it's a good opportunity to again test your tree identification skills. So can you identify this species? This one is definitely on the list of need to know. We've reached a turn-off point in the trail here, and now we're heading towards the river. Notice how the vegetation continues to change. We've reached the start of the boardwalk that goes across the Little Campbell River. The tree on the right is one of those that you need to recognize and identify. It's an indicator species for nitrogen-rich soils. The following slide will show closer images to help you identify it. The bark on these trees often have lichen growing on them, and it gives them a distinctive patchy, creamy, light grey appearance. The leaves are alternate and have distinct wavy margins and a very noticeable veins as well. But perhaps the most interesting aspect of this tree is that it forms a mutualistic symbiotic relationship with bacteria in the roots. The roots have these nodules on them containing bacteria. The bacteria are able to fix nitrogen from the atmosphere and make the nitrogen available to the tree and also release it into the soil, making the soil in near these trees rich in nitrogen. The bacteria benefit from the relationship because they can extract the sugars or food from the root of the tree. So very interesting symbiotic relationship here. It's because of this relationship that these trees are recognized as a good indicator species for nitrogen-rich soils. This pair of birds were very cooperative, and they posed for me long enough to take this shot. Can you identify them? Once again, we come to a very open area with grassy and thick scrubby vegetation. But in this case, the change in vegetation is a result of natural influences, not so much human disturbance. Believe it or not, there is a shallow, slow-flowing stream passing underneath this raised boardwalk. The tall grass growing just in front of me is actually in flower, and this unfortunately is another introduced invasive species. It's called reed canary grass, and it's commonly found in very wet areas along streams and in gullies. The thicker shrub layer behind the grass is mostly made up of a plant known as hardhack, and this is a native plant that is very well adapted to wet, boggy soils. So it's growing very abundantly and thick through this area. Behind that you can see a row of trees, and these are growing on the banks of the stream where it's a little drier. So here's a fun little test to see how observant you are. If you read the sign, there are supposed to be 5 different organisms or evidence of organisms in this image here or illustration. See if you can pick them out. Here we get a closer view of hardhack with its very attractive purple flowers. While it's not one of the plants you need to know here, if you plan on taking the ecology course, it's definitely one of the wetland plants that you'll need to learn later on. Well, we're on the other side of the river now, following the trail back towards the car park. Here we see a beautiful specimen of a large tree. You can see very clearly the thick layer of moss and lichen that's growing on its trunk. This tree, which you should be able to identify, often has licorice fern growing on it. And this is another symbiotic relationship. In this case, it's commensalistic, which means that the licorice fern gets benefit because it's growing higher up off the ground and is able to obtain more light. But the tree, it doesn't receive any benefit from it, but it's also not harmed by the relationship. So it's a kind of a neutral effect for the tree species involved. And this is why it's called a commensalistic relationship. Have you ever been on a forest walk and seen a tree growing that appears to be sitting on a dead log or a stump like this one? Have you ever wondered how the tree got to grow like this? The dead log, or in this case stump, is called a nurse log. And what happened is that a number of years ago, the seed from this tree would have landed on top of a dead stump, and started germinating and growing. So as this little seedling started to grow, the shoots grew up to get light, of course, from the sun, and the roots grew downwards, but they're doing so from the top of this stump. So the roots penetrate down into the dead stump wood as the stump is slowly decaying and being broken down by bacteria and fungi. And as this stump is decaying, it releases some of the nutrients that was stored in the organic material. And these nutrients are now available to be absorbed by the roots of this new seedling. So this is why it's called a nurse log or nurse stump, because the dead stump provides minerals and nutrients that assist in the growth of this new young seedling. As the seedling continues to grow, the roots penetrate down deeper and eventually finding the soil and grow down into the soil, providing the tree with greater support. And as the stump continues to break down and decay, it exposes the tree roots so that they become visible. Can you identify the type of tree growing on this stump? It's actually a red cedar, but western hemlocks and red huckleberries are also very commonly found growing on nurse logs. The soils in many of our local forests are surprisingly quite poor in nutrients. So any tree or species that can grow on a stump or log like this and get a head start in life by obtaining extra nutrients from a decaying stump really provides the tree with an advantage. Eventually the stump will completely rot away, leaving the roots of the tree partly exposed.